This is the second lesson for the second semester, and this lesson I'm going to entitle The Rule of Ones. Now, the rule of ones is a logic problem. It involves making a comparison of two different sets of data. Let's take a look. First of all, we know that this is involving Coulomb's law. And then secondly, we've got a question that doesn't really give us a set of numbers, but gives us a situation where things are changing. So let's read this question. It says, what happens to the force if the second charge is doubled and the distance is cut in half? Okay, so they haven't given us any numbers, but they're wanting to find out what's going to happen to the force if these things occur. So this rule of ones looks like this. I usually set up the very first part of the equation where the force is equal to 1 times 1 times 1 divided by 1 squared, like that. And everybody knows that that's going to just be 1. This establishes what the values would be for the first scenario. Now, some of you are going to be looking at that and saying, well, those aren't really the values for those letters. And that's true. But the k is a constant, and even though we know that it's 9 times 10 to the 9th, it's so much easier to have a constant that has a value of 1, and that number's not going to change just like that number's not going to change. And then in a scenario that we have where we can establish that the charges that were given were each had a value of 1 and the distance between them was also 1, then when you write this out, 1 times 1 times 1 divided by 1 squared will equal 1. So now we've established a baseline for what the value would have been under a normal circumstance. Now, the second situation, we're going to write in the values that have changed. So first of all, we know that the k value cannot change, so that's still going to be 1. And in the question, it didn't say anything about the first charge, so we know that that's also going to be 1. But then they said that the second charge was doubled. So I'm going to put a 2 because twice as big as 1 would be 2. Now, the next thing it said was the distance is cut in half. So the distance in the first scenario was 1, so we're going to put 0.5 quantity squared because 0.5 is half of 1. Now, we'll see as we get closer to the end that you'll see how this can fit into the actual problems later on. Okay? So now that we've got all of our numbers plugged in, let's run the calculation. You got 1 times 1 times 2 is 2, and 0.5 squared is going to be 0.25. So 2 divided by 0.25 is going to be 8. So now, by using this rule of ones and using our logic, we can make this assumption that if the values for the force when the actual values were run has a value of 1, and we make these changes, then we would expect that the value for the force should be 8 times greater. Does that make sense? If this was a value of 1, then this is going to be a value of 8. So this is 8 times greater than this. Now, in an actual problem, you would have numbers that don't automatically show you that ratio. It's a 1 to 8 ratio due to these changes. And each time we run this rule of ones, it'll be compared to what happened in the initial one. And so if the initial one is 1, how did it change? Okay, and so the calculation shows that it's 8 times greater. Now, let's look at this problem from a different point of view and let's see what happens. Let's go into the question that we had initially. I'm going to change colors here right quick. And let's change the second charge is cut in half. Okay? And the distance is doubled. which is another possible scenario that could occur. And again, they don't give us any numbers where we can actually run 9 times 10 to the 9th times, blah, blah, blah. So we're using this rule of ones again. So in the beginning, FE over 1 is equal to 1 times 1 times 1 over 1 squared, which is 1. Now, let's write the second scenario here. It's where the force is equal to 1 times 1 times 0.5, because it said that the second charge was cut in half. Divided by the distance was doubled. So if the distance was doubled, it would be 2 squared. Okay? So now, 1 times 1 times 0.5 is 0.5. And 2 times 2 is 4. So when you take 0.5 divided by 4, 0.5 divided by 4 equals 1, the fraction, 1/8. Now, what does that show us? That under these circumstances, if we change these values, then the force exerted on the charged particles will only be 1/8 of the force that it was originally. And so we could establish that relationship 1 to 1/8 as being the changes that occurred overall as a result of the changes that were made on the individual variables. Now, I hope that that will be sufficient. When you look at those questions on the worksheet, I hope that that will make more sense. And again, thank you for watching. Hope you enjoy the outfit and have a great day.